When solving a ppm problem, there's a simple checklist that if you follow it, solving and setting up the ppm calculation should not be a problem. So we're going to go through this step by step, and I've already worked out and tried to record, but it didn't work. One of the problems on the ppm handout that you were given this past Friday in class. It's the question dealing with the fungicide and the 400 milliliter jars or samples of soil. So first things first, when we solve a ppm problem, is we've got to determine whether we're dealing with a solid in a solid substance or a solid in a liquid substance or an aqueous substance. Now, the reason we've got to figure out what we're dealing with is that if you're looking at a solid in a solid, you're going to have a different set of equivalencies than if you're looking at a solid in a liquid, or if you're looking at an aqueous solution. So if we look at that question, we see that we're given values that state that if the fungicide is below 0.75 ppm, it will not be effective against mealybugs for African bollards. And we're told that we have a 400 milliliter sample of soil, and that we've measured within that 0.21 milligrams of fungicide. So we want to know what the ppm is there to see if this fungicide actually is going to be useful enough. So right there, when I look at my values, I see that I've got 0.21 milligrams. So this, because it's grams, tells me that this is in fact a solid. Now, the determiner here is going to be what this solid is mixed in. Because if it's given to me, if the substance or the amount that's given to me is given to me in grams or kilograms, then I know I'm dealing with a solid in a solid. But if it's given to me in grams or milligrams within liters, then I know that I'm dealing with an aqueous solution. So you see that we've got milliliters here. We know within our equivalencies, and the equivalencies are written in red here below, we know that we don't have any actual milliliters. So when I see these values, I see two things. I see, number one, that I've got a solid, which is grams, in this case milligrams, in a liquid. The liquid was given to me in milliliters, which brings me to the second thing that jumps out at me when I see these values. Nowhere in my equivalencies do I have milliliters in the denominator. I only have liters. So that tells me that I'm going to, in fact, have to convert this to liters. So I've just determined, number one, that I actually have a solid in a liquid. I've got an aqueous solution. This means that I'm going to have to choose my proper equivalencies. Okay? Once I've chosen whether I'm dealing with a solid in a solid or an aqueous solution, I'm now going to have to choose the proper equivalency to set up my actual ratio. And in order to do that, I need to look at my units that I've actually been given. It's easier to actually choose an equivalency where you don't have to do any converting. Unfortunately, that's not always the case, as we see with our values here. We see that we were given 0.21 milligrams, okay? And the milligrams should be a really big hint for us, because if we know our equivalencies in an aqueous solution, we know that 1 part per million is going to be equal to 1 gram in 1,000 liters, or they've given to us, a 1,000th of that, which is 1 milligram in a liter. I have milligrams, therefore I should use this equivalency because I don't have to convert. And if I don't have to convert my numerator, then I know that this is okay. Now, the second thing I have to do is I have to make sure that I have the proper denominator. I don't. I have 400 milliliters. So I'm going to convert that to liters, and if I divide it by 1,000, I get 0.4 liters. So now I have my proper equivalency. Okay, I've chosen the right one. Now I'm going to set up my ratio of what I was given in the problem to determine how much or how many ppms I actually have. And in order to do that, that brings us to this actual section right here. So I was given 0.21 milligrams in a 0.4 liter solution. And 0.21 milligrams to 0.4 liters is going to be equal to X milligrams in 1 liter. Okay? And in order to do that, I've got to cross multiply. So in this section here, I've written out my actual cross multiplication. So if I cross multiply 0.21 milligrams times the 1 liter, that is going to be equal to 0.4 liters times my unknown milligrams. I isolate my my X milligrams by dividing both sides by 0.4 liters. Okay, and in this case, my liters cancel out and my 0.4 liters cancel out here. This allows me to only have the unit that I'm looking for. This is great. This is what I want. So if I work out the math, okay, I've determined step 3 tells me to work out the math and determine my actual ppm. In doing so, okay, I'm 3/4 of the way done. Okay, this is a 4-point checklist. I've done 3 of them. I've found my ppm to be 0.525 milligrams or 0.525 ppm. The last thing we have to do when we're actually doing a ppm problem is to answer the original question. All right, because the math, setting up the math is only worth about 75% of the total point value. In this case, the question was, will the 0.21 milligrams in 400 milliliters be enough to kill the mealybugs? And we know that the mealybugs die when there is a minimum of 0.75 ppm. So I have to actually use my calculations and my answers to actually come up with a solution to the question that was posed. And I have to do this by writing a sentence explaining my reasoning. It's not enough to just say, yes, there's enough, insecticide or fungicide here. No, there isn't. In this case, the mealybugs or the African violet will not be protected because, okay, and this is important, because 0.2 or 525 ppm is less than the required 0.75. So if you can follow these 4 steps to setting up your actual ppm problem, and if you can memorize your equivalencies, you should not have a hard time solving these problems, because mathematically this is simply a cross multiplication. Where it gets a little bit tricky is when we're actually trying to figure out what our equivalencies are. Now, the second way that we can go about solving a ppm problem is if we're actually given, if we're actually given an amount of ppm and we want to know what that is equal to in a certain volume. So my question here was written, and I had worked this out, and of course the recording hadn't worked. So here we had 8 ppm in 500 milliliters. How many, milligrams in 500 milliliters will 8 ppm actually give me? So in order to do that, I know that if 1 ppm is equal to 1 milligram per liter, then 8 ppms are going to be equal to 8 milligrams per liter. if I know what my total volume is for my solution that I'm making, I simply set up my cross multiplication as such, okay, where I've got 8 milligrams per liter is going to be equal to an unknown amount in 0.5 liters. Now, this is a pretty easy math calculation to do, because I know that if I've got 8 milligrams in 1 liter and I've only got half a liter, then I would assume that logically we could come up with 4 milligrams. But to show it mathematically, you would end up with cross multiplying, end up with 8 milligrams times 0.5, giving you 4 milligrams per 0.5 liters. Now you need this much in a solution to give you that same equivalency. So this is pretty much how you solve all ppm problems. You need to memorize your equivalencies for solid in solid solutions and aqueous solutions, solids in liquid solutions.